Welcome to
Welcome to
Welcome to
Welcome to
Welcome to PsychStats tutorial.
one. My name is Matthew, and I'm going to be discussing the statistical test called the chi-squared test. Next, let's say you saw on the internet that the famous chocolate brand named M&M's has stated that their different colored chocolates are produced with certain frequencies, which are on the screen right now. 30 being brown, 20 being yellow, 20 being red, and 10 being orange, 10 being green, and 10 being blue. Next. This somehow got you intrigued and went on to try to test whether this statement is right or wrong. You then opened a few bags that equal to 100 pieces of different colors of M&Ms, and you were able to gather this data. 24 brown, 28 yellow, 13 red, 12 orange, 6 green, and 17 blue. So from here on out, this is where the chi-square test will be in use. Next. The chi-squared test is a method of statistical analysis used to test if the observed collection of data fits what we expect. In simple terms, the chi-squared test is about comparing the data collected and the data expected or predicted. Next. Also, keep in mind that this test is only applicable for categorical data and not numerical. Selections like dog breeds, car types, movie genres, educational achievement, male in comparison to female, and etc., are examples of categorical variables. The main sources of this kind of information are questionnaires and survey results. The most popular method for analyzing this type of data is the chi-square test. When examining survey response data, researchers can benefit from this kind of analysis. Economic and political sciences, as well as consumer and marketing research, can all be included in the study. Next. So, there are two types of the chi-square test, which is called the goodness of fit and independence. Next. So, the purpose of the goodness of fit test is if what you observe is the same or different as what you expected. It is typically used to find out whether the population is normal, which is uniform, or similar to another population with a known distribution. Following are the alternative and null hypothesis. The null hypothesis is the given distribution is matched with the population. The alternative one is the given distribution doesn't match the population. Take note that you can only use this if you only have one categorical variable available. Next. For example, you surveyed 60 people about their preferred mode of transportation, expecting that the result would be equal. So what you expected is that 20 people would prefer using their own vehicle, 20 people would prefer using apps such as Move It, Joyride, Cast, and etc. And 20 people would prefer the traditional means of transportation, such as MRT, LRT, jeepney, and bus. But what you observe is that 15 preferred using their own vehicle, 25 preferred using Move It, Cast, and etc., and 20 preferred the traditional means of transportation. Next. The next is the test of independence. The purpose of the test of independence is to determine whether there are connection with two categorical variables. This is to see if one variable affects the other and vice versa. In simple terms, this is to know if the two variables are dependent or independent. So for the null hypothesis and alternative hypothesis, the null would be the two variables are independent. The alternative hypothesis would be the two variables are dependent. Next. For example, you wanted to know if a person's gender influences mode of transportation preference. For men, 40 preferred using their own vehicle, 30 preferred using Move It, Angkasin, etc., and 30 preferred the traditional means of transportation. For women, 20 preferred using their own vehicle, and 50 preferred using Move It, Angkasin, etc., then 30 preferred the traditional means of transportation. Next. Last, the formula for performing the chi-square test is chi-square equals the summation of observed frequency minus expected frequencies squared all over expected frequencies. That's all. Thank you.
Hi everyone, I'm Sophia Nicole Vicencio and I'm going to teach you about the manual computation for chi-squared. So, we will now start the tutorial for the manual computation. For our formula, chi-square is equal to the summation of the observed minus the expected squared divided by the expected value. O represents the observed frequencies, while E represents the expected frequencies. And sigma is the representation of the summation. X squared is the representation of chi-square. Suppose you have observed 100 people who wash their hair every day and those who wash their hair every 3 days. We want to see if there are any difference based on their gender. At the level of 0.05. An individual will fall into 4 types of category. Male, who washes their hair every day. Male, who washes their hair every 3 days. Female, who washes their hair every day. And female, who washes their hair every 3 days. The first step is having a null hypothesis and alternative hypothesis. For our null hypothesis, there is no difference based on their gender. While for our alternative hypothesis, there is a significant relation based on their gender. To make things easier, we'll put the observed values on a table. So, for male, those who wash their hair every day, the observed value is 40. For female, we have 10. And for male who washes their hair every 2 days, we have 5. And for female, we have 45. If we add this by row, we will have 45 for our first row. And for our second row, we will have 55. Now, if we will add this by their column, we will have, for the first column, we will have 50, and for the second column, we will have 50. Overall, their total is going to be 100. The next step will be getting the expected value or expected frequency. So for our expected frequency, we have the formula for it. Row total multiplied by the column total divided by the grand total, which is the 100. For our first expected frequency, we have 45 multiplied by 50 divided by 100 is equal to 22.5. And the second one will be 55 multiplied by 50 divided by 100 is equal to 27.5. For our next step, we will now subtract the observed frequency with the expected value that we got earlier. So this will be 17.5. This will be negative 17.5. This will be negative 17.5. And this will be 17.5. The next step is squaring these values. So after we square them, we will have the total of 306.25, 306.25, 306.25, 306.25. So after getting the squared value, we will now divide this value with the expected value, which is this. So 306.25 divided by 22.5 is equal to 13.61. 306.25 divided by 27.5 is equal to 11.14. Now that we have squared the observed values minus the expected values, and we also divided it with the expected value, we will now get the summation of it, which is 13.61 plus 13.61 plus 11.14 plus 11.14 is equal to 49.49 or 49.5. But since we will use the 2 decimal point, we will have 49.49. After calculating this, we will also calculate the degree of freedom. Degree of freedom is equal to the row minus 1 multiplied by column minus 1. So we have 2 rows and we also have 2 columns. It's going to be 1 multiplied by 1. So we have the degree of freedom of 1. Since the level of significance is 0.05, looking up that to the chi-squared degree of freedom table, we will have the critical value of 3.841. Since we now have the critical value 3.841 and the chi-squared of 49.49, we can now interpret the result. Since the chi-squared is greater than our critical value, we will reject the null hypothesis. So if we write it in mathematical form, reject null hypothesis and accept the alternative hypothesis, since the computed chi-squared is 49.49 is greater than the critical value 3841 at a level of significance of 0.05.
Go. Hi everyone, I'm Misha Mario Garcia, and here's a step-by-step guide on how to do a chi-square test in an Excel. Assume you have your observed and expected data ready. Next. Step 1. Open Excel spreadsheet and enter your categories, observed frequencies, and expected frequencies in columns. Example, category A, observed frequency is 50 and expected frequency is 40. Then category B is observed frequency is 30 and the expected frequency is 40. Category C, observed frequency is 20 and expected frequency is 20. Next. Step 2. Compute the chi-squared components. In a column, calculate the square difference of observed frequency minus expected frequency squared. If observed frequency is in column B, example cell B2, and E is in column C, example cell C2, type the following formula in cell D2. E equals parentheses B2 minus C2 squared. Drag the formula down for all the rows in the column and enter. Number 2. In another column, calculate observed frequency minus expected frequency squared divided by expected frequency. In cell E2, type the following formula equals to D2 divided by C2 and drag the formula down for all rows and enter. Next. Step 3. Sum the values in the observed frequency minus expected frequency squared divided by expected frequency column to get the chi-squared statistics x squared. In cell example F1, type the formula equals sum column E2 parenthesis E2 column E4 parenthesis and enter. Next. Step 3. Calculate degrees of freedom or DF. Compute the degrees of freedom, DF equals K minus 1, where K is the number of categories. In a cell, example F2, type the formula equals count A, parenthesis A2, column A4, parenthesis minus 1, and enter. Next. Step 4, critical value. Use Excel's chi-squared.inv.rt function to find the critical value for a given significance level, example 0.05, and degrees of freedom. In a cell, example F3, find the formula equals to chi-squared.inv.rt parenthesis 0.05, comma F2 parenthesis and enter. Step 5. Calculate the p-value. Use Excel's chi-squared.dist.rt function to find the p-value based on the chi-squared statistics and degrees of freedom. In a new cell, example F4, type equals to chi-squared.dist.rt parenthesis F1, comma F2 parenthesis, then enter. Step 6. Interpret results. Number 1, compare the chi-squared statistics F1 to the critical value F3. If F1 is greater than F3, reject the the null hypothesis, HO, if F1 is less than F3 or equal to F3, fail to reject the null hypothesis. Alternatively, compare the p-value F4 to the significance level, example 0.05. If p is greater than 0 or equal to 0.05, reject the null hypothesis. If p is less than the 0.05, fail to reject the null hypothesis. Sample output table. Category A, observe frequency 50, expected frequency 40 to 1 is equals to 100 and 2.5. B, 3. Category B, observed frequency is 30, expected frequency is 40, equals to 100 and 2.5. Category C, observed frequency is 20, expected frequency is equals to 0 and 0. Chi-squared is equals to 5. Degrees of freedom is equals to 2. Critical value is equals to 5.991. And p-value is equals to 0.082.
So last but not the least, which is performing the chi-square test in SPSS. So first, of course, you need to have a data that will perform the chi-square test on. And in this first one, we're going to perform the goodness of fit test. So with all that in mind, we'll now have to click the Analyze, then to non-parametric tests, to legacy dialogues, then chi-square. You will now set variables, move your observed frequency variable into the test variable list box. In this, I'm gonna choose the recent GWAs of the respondents. After that, we're gonna look here in the expected values. I'm gonna choose here that all categories equal to an equal expected value, but you can also choose to have a specific values if you have one in mind, which you can just put it manually in here. So after that, we're just going to click OK to perform the test. So as you can see, it has now created a full table comparing the observed and expected frequencies. You can now see both the observed and expected frequencies in their own respective column. And at the bottom here, you can see the result from this table. The first thing that we can see is the chi-square value, which is 65.550. This number is important because this is how we tell how much the observed data differs from the expected data. Meaning, the bigger this number, the bigger the difference. Next is our degree of freedom, which is 40. And now for another important number, which is our p-value, 0.07. So as you can see, if the p-value is less than 0.05, it means the difference between the two is statistically significant, not because of any random reason. And in here, you can see that our p-value is 0.07, which is way lower than 0.05, which means that the differences are significant. To make it all easier to understand, the chi-square test found that the actual counts of general weighted averages are different from what was expected. This difference is statistically significant, which is why our p is equals to 0.07, meaning that it's probably not random. Now, on to the next one, which is the chi-square test of independence. You can use this test to see whether two categorical variables are connected and if they affect each other or not. So first, you need a data set that has two categorical variables. Next, click Analyze, then Descriptive Statistics, and then two crosstabs. In here, you're gonna move one variable to rows and other one to columns. So the variables that I'm gonna choose is one is the respondent sex, and the other one is the respondent civil status. Before you run the test, you need to check both of this, which is the statistics make sure that you check the chi-square in here, and for the other one, you need to check both the observed and expected in the under counts. So now you can now proceed and perform the test. So now the table is made, and we can see that here that the respondent's civil status and their sex. So in the bottom section here again, we're going to look at these important numbers. As you can see, our Pearson chi-square value is 41.748. Just like the first one, the larger this value, the more evidence there is to reject the null hypothesis. So the value being 41.748, which is kind of big, it could mean that there is a strong relationship between the two variables. And as you can see here, our degree of freedom is 15. And again, this number is very important, which is the next one, is the p-value being 0.000. This number is very important because the p-value tells you whether the relationship between the variables is statistically significant. So if the p-value is less than the significance level, which is usually at 0.05, you're going to reject the null hypothesis. In this case, the p-value is 0.000, which is much smaller than 0.05. This means that the results are statistically significant, and we reject the null hypothesis. So with that, we can conclude that there is a significant relationship between respondent sex and civil status. So just a brief run through about this. The low p-value being 0.000 and the high chi-square value being 41.748 means that the respondent sex and civil status are not independent. There is a statistically significant connection between these two variables. In simpler terms, knowing a person's sex can help predict their civil status, and the two can be considered as related to each other in this dataset. That's all. Thank you.
Stop ko lang yung record.
Hello, welcome in our statistical analysis video. Greetings, I am Humphrey Delios. Today I'm going to present the one-way analysis of variance or one-way ANOVA in manual computation. First, we're going to discuss what is one-way analysis of variance or ANOVA, how to solve it manually and in SPSS, and its connection to the field in psychology or in psychological research. So, let's begin. So, what is one-way ANOVA? One-way analysis of variance or one-way ANOVA is a statistical technique to compare and to analyze the significant difference of three or more independent groups, which means that this technique is to analyze if there is a significant difference of the mean values of the groups in between. In the field of psychology or in psychological research, one-way ANOVA is often used to compare or to analyze groups such as, for instance, cognitive development or the memory retention ability or the performance of the groups or the effectiveness of therapeutic drugs. Another example of the application of one-way ANOVA in psychological research is educational psychology. For instance, comparing the before and after teaching methods or performance of teachers during an observation. So this is often conducted by teachers who has in higher position, conducting a research study on students' effectiveness of study habits. Next and last, in special education, the evaluation of the effectiveness of the teaching methods for the students with autism spectrum disorder or ASD. In cognitive psychology, where it focuses on the cognitive abilities, This one-way ANOVA is applicable to the psychological research. For instance, the memory retention of college students. So therefore, analyzing the background students' memory retention ability, in the example given of majority of sleeping hours, medication, or food consumption. Next is the evaluation of the comparison of before and after for people with ADHD using cognitive behavioral therapy or CBT. Next, in developmental psychology, analyzing grade 6 pupils' reading comparison rate in 7 elementary schools across Pasig City. And next, examining coping mechanism ability across age groups. One-way analysis of variance or one-way ANOVA is a statistical technique to compare and to analyze the significant difference of 3 or more independent groups. In null hypothesis, there is no significant difference between 3 or more groups. So, if for instance, in null hypothesis, population 1 is equal to population 2 and equals in population 3. While in alternative hypothesis, there is a significant difference from one group to another, or at least one group, or from one another. For instance, alternative hypothesis is equals to population 1 equals to population 2 and not equal to population 3. See this not equal sign, therefore they are not equal to each other. To solve the one-way ANOVA, here's the formula for the calculation of one-way ANOVA. So F value equals to MSBG divided by MSWG, where the MSBG is the mean square of between the groups, while the MSWG is the mean squares of within the group. But at first, we're going to solve the 7 steps to get the one-way ANOVA. By the way, guys, this formula of F value is the step number 7 or the last step. So, first, determine the correction factor CF by using the formula. Second is determine the total sum squares or SS total. Third, compute the sum of squares between the group or the SSBG. 4. Compute the sum of square within the groups or SSWG. 5th, compute for degrees of freedom or the DF. In computing the degrees of freedom, it includes the between the groups or DFBG and the within the group or DFWG. 6. Compute for the mean square by using the equation or the MS. And then it also includes the between the group or the BG and in within the group or the WG. And then the last step is to compute for the F value by using the equation. So this is the F value. Let's have here the example. The researchers conducted an experimental test on the effectiveness of the ornamental plants' absorption of carbon monoxide in different rooms in a house near the polluted area in Manila. The ornamental plants are tested, namely photos, yucca, and Boston fern, to use whether if there's a significant difference between the two groups, or that the 3 groups rather. Use alpha 0.05. So here are the data of the 3 groups. So we have photos, yucca, and Boston fern. But at first, we're going to square these data. So let's start in the photo. So in photos, 2 squared is equals to 4. 4, 16, 9, 81, until we're just going to square the data collected in different rooms. And now, there you have it. We have all these squared values here in x1 and x2 and x3. And next step, we're going to add all these datas in the group. So in photos, 2 plus 4 plus 9 plus 7 plus 15 plus 16 plus 7 plus 3 plus 2 plus 5, you get 70. And in Yuka, 5 plus 7 plus 6 plus 3 plus 30 plus 13 and so on, we got 63. Pause the video if you would like to try to solve on your own. And then we're going to also add this squared values. So in this x1 squared, so we got 4 plus 16 plus 81 plus 42 plus 225 plus 256 41 49 plus 9 plus 4 plus 25, we got 718. And we got also in the x2 squared and x3 squared. And then next we're going to solve for the grand total. So we're going to summation these groups and in the squared groups as well. So 70 plus 63 plus 104, we got 237. And then in the squared value, in x1 squared plus x2 squared plus x3 squared, so 718 plus 560 plus 1420, we got 698. Next, we're going to write down the summation of the data. So the summation of x1 is 70. The summation of x2 is 63, 104, and in grand total we have 237. And the squared value in the xy squared, we got 2698. So, and then next we're going to write down the number of the given data. So in n1, n2, and n3. In n1 we got 10, since the numbers of data here is 10, and in Yuka is also 10, and also in Boston Fern. So all of the data is 10. And then the n total is 30. We're just going to add this up. Next, we're going to write the list of groups. So K. So how many groups we have? 1, 2, 3. So we have 3 groups. After that, we're going to proceed in the first step of solving one-way ANOVA. So at first, we're going to determine the correlation factor by using the formula. So CF, or correlation factors, is equals to grand total squared divided by the total numbers of observation. So summation of GT squared divided by n total. Our grand total here is 237. Sorry about that. And then the total number of observation is 30, or the n total. So squared so 237 squared is equals to 56,169. So 56,169 divided by 30 is equals to 1,872.3. Next step is to determine the total sum square. So here's the formula: SS total equals to the summation of xi squared minus CF, or the correction factor. So So our summation xi squared is 2698 minus our CF, which is 1872.3. So our SS total, or the total sum square, is 825.7. Third is to compute the sum of square between the groups. So our formula here is SSBG is equals to the summation of T1 squared divided by N1 NA minus CF. So our TI here is the summation value of the groups. So we have 3 groups. So the first group is 70 squared. We're going to square that, divide by 10, which is the total number, and we're going to add this up. So the next one is 63 squared, and then the last is 104 squared. So minus in CF, so our CF is 1872.3. So if we calculate all of this, so we got 3937. So we're going to minus 2. If we subtract these two, we got 2064.7. And then we're going to solve for the sum of square. So our sum squares total is 825.7 minus the SSBG, or the sum square between the group, which is 2064.7. So if we subtract these two, we get 1239. Fifth, compute for the degrees of freedom. So for between the group in DFBG is equals to k to 1. So what is k? K is the number of the group. So how many groups we have? 3 minus 1, so we got 2. For within the group, or degrees of freedom within the group, or DFWG, the formula is n total minus k. So our n total is 30 minus the k, or the number of group, is 3, equals to 27. Step 6, compute for the mean square by using the equation. For the between the group, MSBG equals to SSBG divided by DFBG. So our SSBG is 2064.7 divided by 2. So we get 1032.36. In SSWG, we got negative 1239 divided by 27. So we get 45.89. And then the last step, the 7th step, is to compute the F value by using the equation. So to solve this, we have the formula of F value equals to mean square between the group divided by mean square between mean square within the group. So our MSBG here is 1032.36 divided by negative 45.89. So we got negative 22.45. So there you have it. But wait, there's more. So the last actual step is we're going to get the F critical value at 0.05. So to get this, we will going to use the degrees of freedom between group, which is the 2, and the degrees of freedom within the group, or the 27. So to get this, here's the DF table, and then in the left, which is the degrees freedom within the group, or the 27, and then in the top is the degrees of freedom between the group, or the 2. So we're going to start both DFBG and DFWG to get the center point of that. So our critical value is 3.35. So since the F value enters inside the F critical value, or the 3.35, there is a significant difference. So our decision is reject the null hypothesis since the F test value is greater than the F critical value. So that's it for our manual computation in one-way ANOVA test. Thank you so much for watching.
Hey, my name is Dito Pollen, and today I will be showing you how to perform one-way analysis of variance or one-way ANOVA by using Microsoft Excel. This includes performing the test and analyzing the results. So I already have the example data entered already. This data actually have different groups for the results of math test, and each group is in a different column, and then each cell represent different participant scores. So by performing ANOVA, we're gonna be determining if there is a different or significant difference between the average scores measures of three groups. And now let's perform the one-way ANOVA through Excel. So first thing, as we already have the data here, data sets here, all we have to do is go to the data analysis under analysis, click that data analysis, and then it will give you the tools for data analysis. Since we are using the one-way ANOVA, we're going to be using the ANOVA single factor. Highlight that one and click OK. So since we click OK, it will prompt you again this screen. So first thing, we have to go to the input range. Input range are essentially the data we want to run in analysis. So here, and then here. And then once you selected that the input range, let's now click columns and then check the labels in front row. And the next option is to specify your alpha level. And this is essentially your significance threshold. And usually this is set at 0.05, meaning that if the p-value was less than or equal to 0.05, you would reject the null hypothesis and accept the alternative hypothesis. So I will keep this set as at 0.05. And then the output option will give you three options: output range, new worksheet ply, and lastly the new workbook. But I prepared to select output range so it will show the results on this specific screen. So first, if you put or select the output range, all you have to do is just go here and then click here and then hit OK. Now here is the result of one-way ANOVA given by the Excel. And now let's interpret this one. First, we go to the summary. So summary of the data is the analysis. Basically, there is a count, which is the data scores in each group. The sum is just the total value if you are going to add up all those values in each group. And then the average value in each group. And lastly, column, we have the variance. So basically, the variance is the average of the squared differences from the mean. It is a simply measurement of the spread between the numbers in the data set. So underneath the summary, we have the ANOVA, and it is actually split into 3 rows. The first row describes the results when the between group is classed as the source of variation. And then the second row describes the results when the source of variation is within groups. And finally, the last row is just the total, just the simply sum of SS and DF for the first 2 rows. I know you are wondering what does SS, DF, MSF, p-value crit stands for. So I'll be sharing you what thus SS refers to. I mean, source of variation refers to. So first we have SS, and SS refers to the sum of squares. It is between the group. I mean, the sum of square between the groups quantifies the variability between the group of interest. Underneath is the sum of square within groups, and this quantifies the variability within the group of interest. Next, we have the DF, which stands for degrees of freedom. This is calculated slightly different from the 2 rows. To determine the degrees of freedom between groups, you simply subtract 1 from number of the group in the analysis. And since I have 3 groups, 1 subtracted from 3 is 2. So we got 2 under between groups. And to determine the degree of freedom within the groups, you subtract the number of groups in the analysis from the total number of observations. So we have 30 participants, and each group have, I mean, so in total we have 10 number of observation, and then you can just subtract it into 3 groups, and it will give you 27. So next we have MS. MS refers to mean square. You can think of it as an average variation between the groups or within the groups depending on the row you are looking at. And we have p-value and f crit or f critical. So since our p-value is greater than the alpha level of 0.05, we fail to reject the the null hypothesis. Therefore, there is no difference between the means of three groups. In other words, each group on average performance more or less the same on the math test. And to investigate this further, you will need to perform a post hoc test. And there are types of post hoc tests and the available such as Tukey and Bonferroni. But this one will be discussed by the other group. And pretty much it. And that would be the way how to perform the one-way analysis of variance or one-way ANOVA by using the Microsoft Excel. Everyone, my name is Joselito Polhen from 203P, and today I will be performing a one-way ANOVA using SPSS. So here we have our example on the left sheet, and this one will be our data. So researchers want to test a new cologne. They split participants into three conditions: fruity scents, floral scents, and woody scents. Then ask them to rate their satisfaction level on a scale of 1 to 10. Are there any differences between the three conditions using the alpha level of 0.05? Now, let's go into the SPSS. So right now, we're in a data or data view. So this is completely empty. And first thing we need to tell SPSS what variables we have. So I'm going down to the variable values. Here we're going to enter our independent variables, which is cents, and the dependent variable, which is scores. So first, we're gonna be putting cents here, and underneath the cents, we're gonna be input the scores. So right now, you will be able to see the variables by cents and score. So once you input those information needed for our data, we have to also change the label into respondents. Respondents cents, and then respondents scores. So since we're done with our label, we're going next to the values. So we have three values as I mentioned earlier: the fruity scent, floral scent, and woody scents. So kindly click to this, and then you will be able to see this prompt. So these are our values. So one, let's put the fruity scents. Oops. And then put number two as for the floral scents. And then number three for the woody scents. So once you, as you can see, every time you put values and labels, don't forget to click add so that those values can be added into this screen. And then once you put everything needed for the values, you may now hit OK. So once you click OK, we're gonna be going to the measures. So on this one, our measure should be scale, and then the alignment will be like depending on things you want. And once you input those necessary information into variable view, let's now go to the data view. Now here we have total of 30 scores. So we have three groups with 10 people in each group. So that means we're going to fill out 30 rows in SPSS. We had 10 people who got the fruity scents. We had 10 people who got the floral scents, and we have 10 people got the woody scents. So since we fill in those information under variable view, now we go to the data view. So here we have 30 total scores, and we have three groups with 10 people in each group. So basically all you have to do is just put the 10 participants for 40 cents. Oops. Or if it's not showing the first cents, all you have to do is just press 1 and will automatically change into the first group. So since we have 10 participants under fruity scents, let's put the 10 here, and then next would be the floral scents, just the number 2. And lastly, the woody scents, or number 3. But if you want to change that into numeric, all you have to do is just highlight the scents and kindly go on this value labels. Value labels. So it will show you 1 for the fruity scents, 2 for the floral, and number 3 for woody. But if you want to go back to the scent or change this value, all you have to do is just click value labels, and then that's it. And since we entered the scents, now let's get the scores based on their satisfaction levels. So we have to manually input these scores on this. Let's just get the total scores by each group. Now our SPSS data view are complete. So now we have to perform the one-way ANOVA test through SPSS. So first, kindly go to Analyze. Oops. And then Compare Means, and then one-way ANOVA. So since we click the one-way ANOVA, it will prompt you on this screen. Our factors for this one is the sense, and then the total respondent scores will be our dependent list. So once you click that one, you may now hit OK. And here will be the results of one-way ANOVA through SPSS. So here is the ANOVA table, and it will gives us our sum of squares, degrees of freedom, mean square, F, and significance level for the within groups, and total for this experience. And that would be it. Thank you very much. Again, this is Jose Lito Polen from 203P, and thank you.
Good day, everyone. I'm Francine Ariamat, and today I'm going to discuss the software application of the two-way analysis of variance. So first of all, what is two-way analysis of variance? The two-way analysis is a statistical method used to examine the effects of two independent variable factors on a single dependent variable. It identifies both individuals' impacts, which is the main effects, and the combined influences, which is the interaction effects. This method is crucial in psychology where multiple variables often interact to shape behavior, emotions, and cognitions. In psychological research, two-way analysis is applied in areas such as clinical psychology, where you can evaluate how therapy type and the demographics affects the outcomes. And also educational psychology, studying how teaching strategies and students' traits influence one's performance. And also social psychology, wherein you can explore how personality and situational factors affect behaviors. By analyzing these effects, the two-way analysis offers deeper insights into human behavior. It refines the theories and guide tailored interventions, making it an essential tool for advising psychological researches.
So we're going to the next, which is manual computation. So for the manual computation, I'm going to use the example of this website called statology.org. So this is the example of two-way ANOVA by hand. Suppose a botanist wants to know if a plant growth is influenced by sunlight, exposure, and watering frequency. She plants 40 seeds and lets them grow for 1 month under different conditions for sunlight, exposure, and watering frequency. After 1 month, she records the height of each plant. The results are shown below. So as you can see, there is a table. There's a watering frequency, daily, weekly, sunlight exposure, none, low, medium, high. In the table above, we see that there were 5 plants grown under each combination of conditions. For example, there were 5 plants grown with daily watering and no sunlight, and their heights after 2 months were 4.8 inches, 4.4 inches, 3.2 inches, 3.9 inches, and 4.4 inches. And ayan yung naka-red. We can use the following step to perform a two-way ANOVA. Step 1. Calculate sum of square for first factor watering frequency. First, we will calculate the grand mean height of all 40 plants. So, ito, 4.8 hanggang sa 5.5. And then, i-divide natin siya sa 40 overall nitong data. So, ang kinalabasan ay 5.1525. Next, we will calculate the mean height of all plants watered daily. So the daily is here, 4.8, 4.4, 3.2, hanggang 4.8 to 5.8, and then divide to 20. Dahil daily lang, so ang kinalabasan ay 5.155. Next, we will calculate the mean height of all plants watered weekly. So yung weekly naman, which is ito, i-divide ulit sa 5. Ang kinalabasan ay i-divide siya sa 20, sorry. So ang kinalabasan ay 5.15. Next, we will calculate the sum of squares for the factor watering frequency by using the following formula, where m the sample size of group J, summation sa Greek symbol that means sum. Ito, the mean of group J, the ground mean. In our example, we calculate the sum of square for the factor watering frequency to be 20, open close parenthesis, 5.155 minus 5.1525 plus 20, open close parenthesis, 5.15 minus 5.1525 is equal to 0.0025. Step 2, calculate sum of square for second factor sunlight exposure. First, we will calculate the ground mean height of all 40 plants. So, the ground is ito nga, 4.8 hanggang 5.5. Ang kinalabasan ay 5.1525. Next, we will calculate the mean height of all plants with no sunlight exposure. So, 4.8 hanggang here, 3.9. So, i-divide natin siya sa 10 dahil ito. And then, ang kinalabasan ay 4.07. We will repeat this calculation to find the mean height of plant with various exposure. So, mean of low sunlight is equal to 5.1. Mean of medium sunlight is equal to 5.89. Mean of high sunlight is 5.55. Next, we will calculate the sum square for the factor sunlight exposure by using following formula where n, the sample size of group J, a Greek symbol that means sum, the mean of group J, the grand mean. In our example, we calculate the sum of square for the factor sunlight exposure to be 10, open close parenthesis, 4.07 minus 5.1525, then plus 10, open close parenthesis, 5.1 minus 5.1525, again 10, open close parenthesis, 5.9 minus 5.1525 plus 10, open close parenthesis, 5.55 minus 5.1525 is equal to 18.76475. Step 3, calculate sum of square within error. Next, we will calculate the sum of squares within by taking the sum square difference between each combination of factors and the individual plant heights. For example, the mean height of all plants watered daily with no sunlight exposure is 4.14. We can then calculate the sum of square differences for each of individual plant as. So this SS for daily watering and no sunlight is 4.4 minus 4.14, 4.8 minus 4.14 plus 4.4 minus 4.14, and plus 3.2 minus 4.14 plus 3.9 minus 4.14 and plus 4.4 minus 4.14 is equal to 1.512. So, nakuha siya din dito hanggang sa here and then 4.8 hanggang 4.4. And then, we can repeat this process for each combination of factors. SSS for daily watering and low sunlight is 0.928. SS for daily watering and medium sunlight 1.788. SS for daily watering and high sunlight 1.648. SS for weekly watering and no sunlight 0.34. SS for weekly watering and low sunlight 0.548. SS for weekly watering and medium sunlight 0.652. SS for weekly watering and high sunlight 1.268. We can then take the sum of all these values to find sum of square within. Sum of square within is equal to 1.152 plus 0.928 plus 1.788 plus 1.648 plus 0.34 plus 0.548 plus 652 plus 1.268 is equal to 8.684. So, dito natin siya lahat kinuha. And then, itong lumabas na answer. So, step 4, calculate the total sum of square. Next, we can calculate the total sum of square by taking sum of difference between each individual plant height and grand mean. Total sum of square is 4.8 minus 5.1525 plus 5 minus 5.1525 hanggang sa here. 4.8 hanggang here. So, is equal to 28.45975. Step 5, calculate sum of square interaction. So, next we will calculate the sum of square interaction by using the following formula. SSS interaction is equal to SSS total minus SS factor 1 minus SS factor 2 and minus 2 SS within. Total sum of square is 4.8 minus 5.12 and then Kaya hanggang 5.25, 4.8 hanggang 5.5 is equal to 28.45975. Sum of square for the factor watering frequency to be 20, open close parenthesis 5.155 minus 1525 plus 20, open close parenthesis 5.15 minus 5.1525 is equal to 0.0025. Sum of square for the factor of sunlight exposure to be 10, open close parenthesis 4.07 minus 5.1525 plus 10, open close parenthesis 5.1 minus 5.1525 plus 10, open close parenthesis 5.89 minus 5.1525 plus 10, open close parenthesis 5.55 minus 5.1525 is equal to 18.76475. Sum of square within is equal to 1512 plus 0.928 plus 1.788 plus 1.648 plus 0.34 plus 0.548 plus 0.652 plus 1.268 is equal to 8.684. So SS interaction is equal to 2845975 minus 0.0025 minus 18.76475 minus 8.684. The SS interaction is equal to 1.01075. So step 6. Fill in ANOVA table. Lastly, we'll find in the values for the two-way ANOVA table. So here is how we calculated the various number in the table. DF watering frequency. J minus 1 is equal to 2 minus 1 is equals 1. DF sunlight exposure. K minus 1 is equal to 4 minus 1 equal 3. DF interaction, open close parenthesis, J minus 1 as K minus 1 is equal to 1 and is equal to 3. DF within N minus open close parenthesis, J and K minus is equal to 40 minus 2 and 4 is equal to 32. DF total is N minus 1 is equal to 40 minus 1 and ang kinalabasan is 39. So that's the end of manual computation.
And now, I'm going to teach you how to perform a two-way analysis of variance, ANOVA in SPSS. So, we look at how to test the effects of two independent variables on one dependent variables, as well as we check for interaction effects between them, and let's get started. First, let's set up the data in SPSS. Here is a simple example, is we're testing the effect of gender, which is the male and female, the study method, and the test scores. So, here we have two independent variables, which is the gender and study method, and our dependent variables is test score. Before we proceed, we should double check the data types that are set in the variable view, and all our variables should be systematically arranged. As you can see, it is typed by 1, 2, 3 gender, study method, test scores, and we should always put the values here in decimal form. Yan, 1 male, 2 female. And the study method, regular and irregular. And of course, the numerics. You should value that and put the label. So now, let's perform the two-way ANOVA. So here's the first step. Let's go to the Analyze. Click the Compare Linear Model to Univariate. And move the test score to the dependent variables. And move the gender and study method to our fixed factors because that is our dependent variables. So now, let's click to the options, which is here. We should click the descriptive statistics, estimates of effect size, and homogeneity test. And after that, we're going to click the continue and hit OK to run the univariate or two-way analysis of variance. So here is our result. Let's take a look at the result that SPSS gives us. So this table shows that the mean test scores for each combinations, just here, of gender and study method. As you can see, the mean score for males is in group is 82.50 and the total of it is 86.75, while the female have on group side is 76.50 and the individuals is 89.50 and the total of it is 83.00. So, yeah. This table presents a two-way ANOVA examining the gender and the study method. On the test scores, the model is significant for the F statistic for the model with 3 numerator degrees of freedom and 4 denominator degrees of freedom is 15.284 and the model explains of it as 92% of the variability in test scores, indicating a very strong relationship between the predictors, between gender, study, method, and their interaction. And this test scores is the study method significantly affects the scores because P is equal to 0.003. Like this. Okay na. Ba't nag-iba yung boses ko? And that's it. You've now learned how to perform and interpret a two-way ANOVA in SPSS. This method is powerful for exploring how two factors interact and influence your outcome variable. If you have any more questions or want to see more tutorials, leave a comment below and thanks for watching. Bye! And now, our next presenter, Antoinette Amar, will discuss the application of two-way analysis of variance using Excel.
So let's how to use two-way ANOVA in Excel. This I'll use another website for this, and this called goskill.com. How to use two-way ANOVA in Excel. With the data analysis toolpack installed in your data in columns, you can perform the following step in Excel to get the result of two-way ANOVA analysis. You'll begin as you did for one-way ANOVA. Follow along with the two-way ANOVA step. Number 1, click the Data tab here, and step number 2, click Data Analysis. Number 3, select ANOVA, two-factor with replication and click OK. Ito, then OK. Step 4, next to input range, click the up arrow. This one, as you can see. And step number 5, select the data and click the down arrow. As you can see, ayan. Select the data and click the down arrow. Step 6, in rows per sample, enter the number of measurements in the group, then click OK. Ayan. Ito ang example, as you can see. In this data, you can see the rows 2 to 15 have the measurement for the first box type. Those rows have 15 data points since the groups all to have the same amount of data for the analysis to work in Excel. We know that the second box type must also have 15 rows. So, result for two-way ANOVA and Excel summary statistic. As with one-way ANOVA, your result will come in two parts. The first part will be summary statistic about your groups. And then, ayan. The blue highlighting shows the overall average for two different box types in the data. The difference is about 0.67 kilograms. The gray highlighting shows the average for three different types of suppliers. The average for tape supplier 3 is closest to 10, while the average for tape suppliers 1 and 2 are closer to 9. The average for the individual groups have gold highlighting if the tapes from different suppliers all work the same on both types of boxes. Then, the average for the individual groups should follow the same patterns. The average for box type 1 should be higher, and the average for tape supplier T should be higher. The group average show a different pattern than the overall average for two factors. Tape supplier T's average is higher than the other two because there is larger difference between the supplier for the second box type. This comparison of the average should prepare us for what to expect about the null hypothesis for two-way ANOVA, that the factors do not affect the response variable. Results for two-way ANOVA in Excel hypothesis test. For one-way ANOVA analysis, the p-value was relatively large. The value led us to conclude that we couldn't be certain whether there was any difference between the types of layers. For two-way ANOVA, our largest p-value is about 0.002. That is much smaller than traditional cutoff value for statistical significance of 0.05. And yan, table. Because the p-value for the interaction is small, we cannot make a simple statement that one supplier or box type leads to a higher field strength. The hypothesis test confirms that we might have expected from the examination of the average the effect of the different types depends on the box type. We could equivalently say that the effect of the different box type depends on the state. From the default results in Excel, you can conclude that not all the groups have the same field strength. To make a more precise statement about the relationships among the groups, you should proceed to a multiple comparison analysis. So we're done for the manual and Excel computation and methods. So for the overall conclusion, two-way ANOVA is the best method for determining if an overall meaningful difference exists. When the observed data contains two or more groups, to use this method, four assumptions must be met: normality, sample size, equal variables, and independence. The dataset should have normal distributed observation, equal variances for each group, and observation in each group to ensure a comprehensive understanding of the relationship between the variables. Two-way ANOVA can be applied to other forms of analysis such as linear regression if the dataset meets these criteria.
So for our overall conclusion, this tutorial provides a clear and concise guide to performing and understanding a two-way analysis of variance in psychological statistics. Aimed at students and professionals, this video explains how to examine the effects of two independent variables on a dependent variable, and it identifies the potential interaction effects between them. Viewers will also learn the step-by-step process of setting up the hypothesis, interpreting main and interaction effects, and understanding the importance of statistical significance in experimental research. Using the real-world examples, the tutorial simplifies the complex concepts, helping viewers grasp the relevance of two-way analysis in psychology and other fields, of course. Many have found this tutorial invaluable for demystifying statistical analysis, enhancing their confidence in conducting any research, and improving their ability to critically evaluate scientific studies. By the end, you'll have the tools to apply the two-way ANOVA effectively in your own analysis.
If you are watching this part, it means you have learned what is chi-squared, one-way analysis of variance, and the two-way analysis of variance. Now, let's recall what we have learned. The chi-squared test is a statistical technique used to compare observed and expected data in various fields such as economics, politics, consumer, and marketing. It is also used to categorize variables like dogs and car types. Meanwhile, one-way analysis of variance, or one-way ANOVA, is a statistical technique used in educational psychology, cognitive psychology, developmental psychology, and research to compare and analyze significant differences between groups. It is used in various applications, such as comparing teaching methods, evaluating students with autism spectrum disorder, analyzing memory retention, and examining reading comprehension rates. Lastly, the two-way ANOVA is a crucial statistical method in clinical psychology, educational psychology, and social psychology, providing deeper insights into human behavior, refining theories, and guiding tailored interventions. We also tackle the different applications of chi-square, one-way analysis of variance, and two-way analysis of variance. We have manual computation, Excel application, and lastly, the SPSS application. If you have any further question, feel free to comment down below and hopefully we can answer your questions. Thank you for watching!